All right, welcome back. We're going to look at example 2. So, what we have for example 2 is we have a proof. We're given this information. We have to prove this. We are given a 2-column proof, and then we need to write it into a flow chart. Okay? So that's what we actually have to do for the problem. But first, we're going to understand and just spend a lot of time right here and just kind of think for ourselves before we just jump in and just look at what they're telling us. So, what it says is that given B is the midpoint of AC, so B is the midpoint of AC, we need to prove that 2AB equals AC. Well, if you remember, whenever we talked about the midpoint of AC back in chapter 1, we talked about 5 formulas, right? So the first one was that just AB is equal to BC. The second one was that, we can have 2 of these ABs, and that can equal the whole thing, AC. Or we can have 2 of the BCs, and that can equal the whole thing, AC. Or 1/2 of AC is equal to AB, or 1/2 of AC is equal to BC. And then we could say all of these because of the definition of a midpoint, right? Definition of a midpoint. So, what you need to realize is that from here, B is the midpoint of AC, and we need to prove AB is equal to AC. Well, that is right here. Boom. So we can just go from here to here because of definition of a midpoint. Boom, we're done. But what you need to understand is sometimes in life, here's your little home, and this is you, this is your home, okay? And then let's say this is, I don't know, grandma's house, all right? Now, whenever you do proofs, there's multiple ways sometimes to do a proof. And sometimes there's what I like to call a direct road, right? The shortest distance between 2 points is a straight line. Well, this is the straight line. B is the midpoint of AC. We can prove that, boom, by definition of a midpoint. Okay, that is the direct path. However, sometimes if you're trying to go to grandma's house, what you can do is you can go on what I like to call the long, windy road, where you go here, I don't know, you go over here, you go circle back, you go here a couple times, and then you go out, and then, finally, I think we're going to get there, but no, not quite, and then there we are, okay? So we still ended up at grandma's house, but we went on the long, windy road to get there. So what you need to understand is, even though, yes, some of you realize, hey, I can directly get through there through the definition of midpoint, that's the direct pathway, what they're going to be doing in this proof, which they want us to write as a flow chart, is more of a long, windy path. Okay, so I just need you to understand that before we get started. So let's see what type of long, windy path they go on. So what happens is we state that B is the midpoint of AC. Okay, now from that, they say that AB is congruent to BC. AB is congruent to BC. That's cool, that's fine. That's just, they use our first equation here, right? Okay, that's fine. So they're using that by definition of a midpoint. Then, because we need this format, they change it into the equals by the definition of congruent segments. All right? Then what they do is they go from here. AB plus BC equals AC, right? Because this is a segment addition postulate. So AB plus BC equals AC. So segment addition postulate. And then what do? Well, instead of, what are we trying to do? We're trying to get 2 AB. So we have 1 AB. We just need another one. So instead of writing BC, they know that AB is the same thing as BC. So they just substitute, instead of BC, they substitute in another AB, right? Then you add them together and you get 2AB equals AC, which is exactly what we need to prove up here. Okay? So it's the same way of you get the same thing. This is just more of a longer pathway than just saying, hey, this is the given information. We can say this because of definition of a midpoint. All right? So what we need to do is we need to take all of this information and put it into a flowchart proof here. So to do that, we need to understand how flowchart proofs work. So basically what this is saying is you're starting with something. From that information, you build onto it, and then you build on it to it again. So that's basically a 1, 2, 3 steps from this information. Over here, you have one step and then you build on it. Well, actually, it's just one step. And then what happens is these two worlds combine, usually through substitution, and then you end up pretty much with your answer here. So we need to figure out, well, what do we put over here and what do we put over here? So, well, we should know what is the substitution piece, right? That's going to go here, is whatever gets substituted together. Two pieces collide. But this is a 3-step process. So we need to look at here. Is there something that you start somewhere, then you build and build to 3 steps? So let's look here. We have B as the midpoint of AC. Okay, that's 1 step. And then we go ahead and say AB is congruent to BC. That's 2 steps. And then from that, we build on it again for 3 steps. And then we get here, and this is basically a brand new thought, right? So this really shows your 1, 2, 3 steps. So that information is going to go here in your 1, 2, 3 steps. Okay, so that's what we're going to do. We're going to write that information in there. So first, we start with B as the midpoint of AC. So B is the midpoint of AC, and then you put the justification for it here. That's just given information. Okay, then we build upon this by saying line segment AB is congruent to line segment BC. So line segment AB is congruent to line segment BC, and we can say this information off of that because of the definition of a midpoint. So the justifications always go below the circle to the right. Okay, now from here, we're going to build off this again. This is our 3rd step, and say that AB is equal to BC, so we're just changing the format. And we can do that because of the definition of congruent segments. Okay. Then basically we just have a new thought. This is something new. All right. Okay, and then what happens is we use these 2 pieces of information to substitute and get this. So this piece right here is the new thought, so we have a new column for it. So that's going to go over here. So we're going to write AB plus BC equals AC, and that is the segment addition postulate. Okay? And then we have both of these pieces of information coming together through substitution and having a mathematical geometric baby. Okay? And this is the baby they have, and it goes right here. Okay, so we put the geometric baby here, the proof baby. It's such a cute little sweet baby. Equals AC, right? And we can do that through substitution. And then what do? We just add, right? So we just simplify, and we get 2AB is equal to AC by just simplifying. And there we proved it. Simplify. Boom shakalaka, there we go. All right, so this is just showing how to take a 2-column proof and write it into a flowchart. But really, really take the time to understand what's going on, okay? All right, so let's do the next example. What do we have? What do we have? Okay, here we have it. All right, so check it out, example 2. We're given that angle 2 is congruent to angle 4. So these two angles are congruent. What we need to prove is that the measure of angle 1 is equal to the measure of angle 3. All right, cool. So we're going to think about this first, okay, before we look at everything. So what do we know? We know that these two angles are congruent. These two angles are the same, right? Sometimes I like to put numbers on those, right? So let's say this was, I don't know, let's say this was 50 degrees. If this was 50 degrees, then this would have to be 50 degrees. And if you see, right, they're on a line. There's these two angles on a line, which means they're a linear pair, which means they're supplementary. So that means they have to add up to 180. So if this is 50, what does this have to be? Well, this has to be 130. And if this is 50, what does this have to be? Well, this also has to be 130. So you see that we have to prove that the measure of angle 1 is equal to the measure of angle 3. Well, we can see that they are equal, right? And so therefore, we can prove it. But what did we do? We established that these are the same, right? And then we know that these are a linear pair, right? So it's kind of looking at it just like when you look at a problem like this. You know you have two segments and a whole. This is a segment addition postulate, right? You have that in your tool belt. You have to know that when you look at this and you see a straight line, you see two angles, that this is a linear pair. So that means that angle 1 and angle 2 are supplementary and they add up to 180 degrees. You know all of that information just by looking at this and the knowledge that you already have from the, the first chapter and half of the second chapter as well. Well, almost all of the second chapter, really. Okay, so let's go ahead and see what's going on. All right, so let's look at the first part. So basically, angle 2 and angle 4, that's given, right? We know that those are the same. And then what happened? Well, in the proof, they state that angle 1 and angle 2 are supplementary. And angle 3 and angle 4 are also supplementary because of the linear pair theorem, okay? Now, this is the tricky part. Angle 2 and angle 4, they're the same, right? So I'm going to put this. They are the same. So basically what we have is we have two angles that are supplementary to the same angle, because even though they're different, they're the same. We've established here that they're the same. Angle 2 is congruent to angle 4. They're the same angle. So because we have two angles that are supplementary to the same angle, what we can say is that those two angles are congruent to each other because of the congruent supplements theorem. Do you guys remember that? We talked about that either last section or the section before, the congruent supplements theorem. When you have two angles and they're both supplementary to the same angle or to two angles that are equal to each other, therefore those two angles are congruent to each other. So that's kind of nice. All right, so we have angle 1 is congruent to angle 3 by the congruent supplements theorem. And then we just need to change the format, and we get measure of angle 1 is equal to measure of angle 3 because of the definition of congruent angles. So that's pretty much it. So the big, the lock, the key that unlocked the lock was this congruent supplements theorem, establishing that we have two angles that are supplementary to the same angle or two angles that are congruent to each other. Therefore, those two angles must be congruent. And you can see that they are when we stick numbers in there. Okay, so now we just have to go ahead and write this into a flow chart. So if you look here, what do we have? We have one piece of information here, right? And this doesn't really go anywhere. And when I say go somewhere, I'm referring to, remember back here in the last one, we had B as a midpoint, and then it went to here, and then we went to here. So it was like 3 steps, right, off of that given information. For this one, this basically just stays, and then we just start a new thought. And then the new thought is this information right here, establishing that both of the sets of angles are supplementary because of the linear pair theorem. But then that basically stops, and what happens are both of these pieces of information play together to come up with this. And so this is the baby. And usually babies are formed by substitution, but that's not always the case. This one, the baby is formed through the congruent supplements theorem. And what I'm saying is this is parent 1 and this is parent 2, and they come together and they make a baby. So when we're looking at this flowchart proof, we have one column here and we have another column here, and you can see they both come together for the lovely little baby that goes right here. So we're just gonna, it doesn't matter if you put this one here or that one there. We'll go ahead and put this yellow information here and this one here. So we'll say that angle 2 is congruent to angle 4, and that's just given. And then we can put all this information here in this one. Angle 1 and angle 2 are supplementary, and then angle 3 and angle 4 are supplementary. And here we've established angle 2 and angle 4 are the same, so they're basically supplementary to the same angle. Therefore, angle 1 is congruent to angle 3 by the congruence supplements theorem. And then I forgot to say that we could say that those are supplementary because of the linear pair theorem. Yeah, and then for our proof, we just have to change the format, which is what they did right here. So we just go from here to here, measure of angle 1 equals measure of angle 3 because of the definition of congruent angles. And then boom shakalaka, there you have it. That is that proof. So hopefully this all made sense to you. If not, go ahead and rewatch it. I know that when I first started doing this stuff, it took a little bit of time for it to sink in and for me to really get it and understand it. And I'm a math teacher. So if it's taking you a little extra time, that's okay. That's normal. That's what learning is. Learning is a big pot of stew. And I don't know if you've ever made stew, okay? But you get some stuff, you get some liquid, whether it's water or chicken stock, whatever. You put in the meat, you put in the vegetables, but you just don't eat it right away. It's got to simmer. It's got to just cook for multiple hours. It just sits there. All the flavors, they all come together. They go around. It's good. And then after a little bit, you eat some and it's delicious. That's how these things are. You learn about it, and then you got to give it time for you to think about it, for you to process, for you to understand, for you to think through. These are a big pot of stew, okay? So don't get frustrated with yourself, and don't think that you can't do it. You can do this, okay? But just give yourself time to get engulfed in the learning process, because that's what it's really important for you to understand that. I'm not asking you to jump through hoops. I want you to let that stew simmer. I want you to understand it. I want you to believe in yourself. Stay positive, because you can do it. All right? Oh, but we have to talk about this. Oh, this is the congruent supplements theorem. Oh, it just says it again. Okay, it says if two angles are, so in 2-6, we did it last section. So this is just a review. If you don't have this as a flashcard, go ahead and make a flashcard. Congruent supplements theorem, it says if two angles are supplementary to the same angle, then the two angles are congruent. So there you go. Angle 1 and angle 2 are supplementary. Angle 2 and angle 3 are supplementary. They are supplementary to the same angle here. Therefore, 1 and 3 are congruent. All right, awesome. I will see you in a little bit for example 3.